5.4 is the hypotenuse legs congruence theorem, and we're going to summarize all of our congruence postulates and theorems in this section also. So a hypotenuse in a leg can only be used in a right triangle. So you specifically have to have a right triangle. Cannot be used in any other triangle. So if you do not have this right angle, you cannot use HL. HL, hypotenuse, and either one of the two legs. Remember, the hypotenuse is always opposite the right angle. So in this example, is it possible to show that the two triangles are congruent using HL? First off, we can mark JH as a common. You can redraw this so you can see the two right angles. Okay, so opposite the right angle is H, and I have one of the legs. So we have JH congruent to JH, which is the hypotenuse, and then we do have a pair of legs, JG congruent to HK. We're going to use this in order to prove, do a proof. So we've been doing these now for a few days. So we look at our given statements and find them in our givens down here. So here's PR, and here's your PQ congruent to, so you can write given for those reasons. We have perpendicular lines, and then we say angles are right angles. So that's the definition of perpendicular lines. And then we say that we have right triangles. That's the definition of a right triangle, that it has a right angle. Oops, I forgot my N on there. PQ congruent to PS. PR congruent to itself is reflexive property. And now I have the two right triangles congruent to each other. And if you take notice, you do have H, and that center is the L. Just your theorems and postulates all put together with some pictures to demonstrate. So side, 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 angle, side, angle, side, angle, 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 side, and HL. Then we just have some things here, deciding whether triangles are congruent. Does the diagram give enough info to show the triangles are congruent? If you look at both triangles, neither one of them are right triangles. So not right triangles. So you can't use HL. So I look to see if I can use any of the other ones. So in this one, I have angle, angle, side, angle, angle, side. So this one is congruent by angle, angle, side. In the second one, I can mark my center. And I have what? I have side, side, angle. So this is no. And you could say you don't have the included angle, if you wanted to give a reason. So let's look at, again at some examples here. In the first one, I have that right triangle, okay? The angle's not in the right place, but, oops. I do have HL. HL. So this is HL. There's those parallel lines. Parallel lines cut by transversal. We can mark, oops. We can mark these alternate interior angles. And I can mark that common side. But that's not enough info. So that'll be no. And in number 3, you have a couple different things you could do. First off, you can mark the center. You could say that it's HL. You could say that it's side, side, side. Or you could even say side, angle, side, because of the right angle here between two sides. So what is the HL congruence theorem? It's if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle. And that is the end of this section. I do want to make a correction to the homework assignment. Make sure you can cross off 29 through 31. That's it.